All right, so what we're going to do is we're going to build contingency tables in Excel. And they're called pivot tables here. What I'm going to start with is looking at, I don't care. We could either do contracting or human resources, but maybe we'll do human resources. So what I'm going to do is I'm going to copy this data set. And the way to do that is I right click or control click on it. I'm going to move our copy. I'm going to create a copy. That's this little box right here. I'm going to put it at the end of the sheet. And it should show up over here, human resources. Great. Now I'm going to rename it. Click again on it. Rename HR is what I'm going to call it, HR data. I'm going to go down here and strip out anything that's not data. All right, looks like there's no data here. Okay, sorry, no averages, nothing except for just data. Now what I'm going to do is I'm going to highlight the whole thing. And I'm going to write insert. Oh, actually, you know what? Let's do it from the other bar. Let's do it from the other one. So I'm going to click insert pivot table. So it says select the range. Once again, if you didn't have everything highlighted, you'd click on this white button with the red thing, and you'd go and select the data that you want. I'm going to have the pivot table in a new worksheet. So I'm going to click OK. And what it's going to do is it's going to pop up this little format. I'm going to rename it, this sheet, real quick. I'm going to call it HR pivot. Okay. On this page, I don't want to mess anything up. So this human resources data that I just stripped everything out of, I don't want to do anything else on this page because this is the data from which I'm going to draw all of my information to build into this pivot table. Now, let's say, for example, you click off of this and all this black goes away. Don't freak out. Just click back into the pivot table itself. Okay. Now, what we're going to do is we're going to build essentially these contingency tables, but we're going to do it in Excel. Now, the way to do that is we select which variable we want where. So let's put, for example, we'll put gender in the columns, male and female. And then we want to see if, let's say, there's a difference in level of education. I put that in the rows. So when you're trying to figure out if you're doing it right, look up over here into the fields. It'll say which one is which. The columns are the X variable. We think that there's a difference between males and females when it comes to education, at least in this data set. So genders in the columns, it affects education, we think. Now the values over here are the count of gender, or it could be something else. If you click on the little I button, it'll say, what do you want? Do you want the sum, add them all up, the count, the average, the min, the max, the product, the standard deviation, variance, whatever this is. This is one way to generate averages and standard deviations for your variables. You can pull those into a pivot table. I think we did that already. If not, I can show you how to do that again. But the counts are useful because we want to figure out what percentages are there. So there were 16 males and 22 females who had bachelor's degrees. So look, more females had bachelor's degrees than males, right? Yes, but there were also nearly 40 females and half as many males. So is this right or wrong? You can't really do a proper contingency table with this. This will help you see data, but what you're going to have to do is you're going to have to copy all of this. So we hit Control C, copy. We're going to go to a new page. Then we're going to go over here and we're going to right click, paste special, and just the values. Okay. Now, if you paste the formulas or paste something else, you end up having a problem. And if you want to try and have that problem, you're more than welcome to have it. It's a bummer. But okay, so we have this count. What I want to do is take this and make it more usable. So what I'm going to do is I'm going to copy it. Hit copy. I'm going to paste it over here. Okay, now what I want to do in a contingency table is try and figure out percentages. And I'm going to put this line here so that you can see where we're at with percentages. Put a bottom border here. So 38 out of 61 people had bachelor's degrees. Okay, what I'm going to do is you could do something like 38 over 61 to get a percentage here. But what I'm going to do is I'm going to show you a trick that's going to be helpful. So I'm going to hit equals. I'm going to hit over here in the observation column, 38 divided by 61. Okay, so when I reference this, we have the information being drawn from the numerical table. We're going to generate something over here. This is going to help us understand what's going on in the table. And then I'm going to change these to percentages so that you can see what's going on here. Okay, now I'm going to hit equals. I'm going to do it again. 12 over the total. There. I'm going to do this again. Equals, this instance, 11 over the total. Okay, now when we look at this, we say, okay, 62% of the people in that data set had a bachelor's degree, 19% had a graduate degree, and 18% had high school. If I really were like being picky about it, I would go back and resort these so that I had high school, bachelor's, graduate. It's all out of sorts, and honestly, it makes me a little bit frustrated. So maybe what I'll do is I'll do it anyway. So you can click on this. You click insert. It's going to create a row here. I'm going to cut here. I'm going to paste it here. Okay, now I'm going to just double check my formulas. I'm going to delete this row. Make this go away too, because it's not where it should be. Okay, great. So double check. So if I double click on these things, it'll show me, okay, is this what I want? Yep, high school. Yep, 11 over 62, perfect. Double check, yep. Oh, yep, bachelor's degree, total. Okay, great, right. Double check again. Okay, got it. Now, power of Excel, because I've set it up this way, I can drag this over and copy the percentage formulas. Because I'm referencing this table and not itself, it's going to work. 3 over 37, blah, 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 blah. Okay, great, perfect. So if I were writing a report, I would use this and I would put this table in the report. So we looked at restating the hypothesis, looked to see if there's a difference between males and females when it came to education. Males had about 33% high school. Females had about 8% high school. So 20, whatever, 6-7% more males had a high school degree than females. So this is the formula to do this. Group percentage, different by this much to this group percentage. Okay, cool. There we go. Now, in Excel, we can't really calculate statistical significance without generating the observed and expected. So how do we do that? Well, this is what we actually observed. How much would we expect? Well, what we'd do is we'd go over here and copy this again. I'm going to put expected. This is observed. And if you go back to the lecture, you'll see, how do we get these information? Well, you go, this should be this percentage, and this should be this percentage, and this should be this percentage. Oops, I messed up there. This should be this percentage. Okay. Now, how many people should we actually have? Well, if we are if there's no relationship between males and females, then 18% of all the people will have high school degrees. 62% would have bachelor's degrees. I'm going to zoom in for you so you can see this more. And 19% would have graduate degrees. So how do we do that? Well, we say equals this percentage times this. Equals this percentage times this number. Equals this percentage times this number. Now do the same thing over here. Equals this percentage times this number. Equals this percentage times this number. Equals this percentage times this number. Now, if you go back and you look at the lecture, I give you an example of this and like why it works and how it works, but this is how you do it in Excel. So now what I'm going to do is I'm going to put chi-square p. Excel is pretty great. It'll tell you how to calculate the chi-square value. The chi-square from the lecture is a measure of the difference between what we observe and what we expect. So I'm going to try this right here. Equals chi, and look, there it is. Yay! Chi-square test. Actual range. So now I'm going to go over here and highlight what we actually saw between the males and the females. We do not include the grand totals in either side, just the marginals. I'm going to put 0 here. Actually, I got to go fix this real quick before I do this. Empty cells do weird things, but that was actually a 0 in that cell. So I'm just going back and filling it in. Equals chi square test. Actual range. Over here, those are the males and females and the different degrees. We have 2 genders and 3 education levels. So then I follow the instructions in Excel. Chi-square test. Okay, actual range, comma, expected range. Well, why did we need the expected range? So we could make a comparison. So these are the ones that we are going to compare it to. And we hit that parenthesis, hit enter, and that gives us a probability. So if you wonder about how to calculate this, you can go and review the recording. But really what's going on here is we're trying to figure out how many we should expect if there's no difference between males and females. The if there's no difference between males and females is the null hypothesis. But we want to compare what we actually see over here with the null hypothesis. We generate the null hypothesis based on the distribution of the outcome variable, assuming that there's no difference. So how many males were there? 24 times 18%, that gives this number. Anyway, long and the short of it. So if I'm writing this up, is I would say, we ran a test to see if there's a difference in education levels between males and females. Okay, when I look at the big broad patterns, what do I see? Actually, the females are more educated overall than the males, because the male lower levels of education and the females have higher levels of education. But I can't compare across all of these at once. I have to compare within the row. So I would say something like males had 7% more bachelor's degrees than females. Group, percent difference, group. Males compared to females was a 7% difference. Females had 32.4% more graduate degrees than males. All of them had graduate degrees. Like all the people who had graduate degrees were females in this data set. So group, difference, group. Females, 32% different than males in the graduate degrees. Now, here's a weird one that you should just be aware of. This grand total over here, this percent total, this is the null hypothesis. This is the no difference. There's no difference between males and females. We just want to see overall who had high school degrees. 18%, 62% had bachelor's, 19% had graduate degrees. So we could compare to the null hypothesis as well. So for example, males had 19.6% less graduate degrees than what we expected. Then what we expected is the null hypothesis. Males had 4.4% less bachelor's degrees than we expected. males had 15% more high school degrees than we expected. Okay, so when people lie with statistics, they're not lying with the actual data, like the calculations. They're not, that's not what you do. What you do is you make comparison to groups that either don't mean very much or make you look better. So for example, if you're talking about female achievement, you would say 32% more females than males had graduate degrees. That's huge, right? But when you talk about males, or sorry, females to what they expect, this is only like about 12% different, 12.5% difference. Females had 12.5% more graduate degrees than we expect. Well, which is it? Is it 32% or is it 12%? It's both. That's why you have to say group compared to which group on which category and how different are they? So once again, grand total, this is the null hypothesis, and these are the two groups. So if I were reporting this, I would make some comparisons, male to female, male to what we expect, whatever it is you want, percent differences. And then I would say, we found statistically significant differences. Chi-square is p less than 0.001 in this instance. So they are statistically significant differences. They're both statistically significant, but they're also substantively different. That means to say there are big percentage differences between males and females when it comes to education. Okay, so how did I get there? I started with the data. I cleaned up the data to make sure that there weren't any problems. There weren't any calculations in there. They were just values. I went over, I highlighted them, I inserted a pivot table on a second sheet. The pivot table, I put in the variables where I wanted to put them. X value in the columns, Y value in the rows. Independent variable in the columns, dependent variable in the rows. Now the values I wanted to check to make sure that we had counts. You can switch these to other things. You want the count of the columns, okay? Then I copied this and I put it in a separate sheet. And I pasted the values only, paste special values. This gives us our observed values. I converted them into percentages. I converted them into percentages using, pretty standard formula. I looked over here and what we actually saw, converted them into percentages. I did that so we could make comparisons, substantive comparisons. Then I went over here and calculated what I would expect based on the null hypothesis. And you can, once again, go back into the lecture video to figure that out. Then I went and I calculated the chi-square test. Chi-square is observed, the raw numbers, not the percentages, the raw numbers observed, and then you hit comma, and you highlight the expected numbers over here. And then you hit parenthesis and a parenthesis, and it gives you probability. Now, if you really, really wanted to, you could do the inverse of the chi-square to generate the chi-square value. The test statistic. And that would you go equals chi-square test inverse, chi-square inverse right tail inverse. Okay, great. So this is the probability. So we click on the probability first that you just calculated, comma, then the degrees of freedom. Now, if you go back into the lecture, it talks about the number of columns minus 1 times the number of rows minus 1. So we had 2 columns minus 1, 1. 3 rows minus 1 is 2. So 1 times 2 is 2. So put that in there. That doesn't look right. Degrees of freedom. Let's try, let's see if it does RT, if that's the better one. There it is, RT. So this one is chi-square dot inverse dot RT. That's how you get your chi-square number. So if I were writing it up, I would say we conducted a statistical test to see if there's a difference between male and female. We found a statistically significant difference. Parenthesis, chi-square equals 13.0, comma, p less than 0.01, and the parenthesis, and then make some substantive comparisons. Okay, that's chi-square. That's how you do pivot table. Now, here's the cool thing about pivot tables. As long as you don't mess with the data, where the data came from, and you keep the pivot table intact, you can go out here and you can unclick gender. Like, I don't want to compare gender and education anymore. I want to compare something else. And you could pull these in. Interestingly, like maybe you think that education affects, you drag it into the column and you think it affects, client complaints or something like that. Now, this isn't the exact what you'd want to do, because we don't have like another ordinal level measure. But if you did, you'd throw that in the rows. Instead, let's do something different. Let's look at the average number of client complaints. No, average of client complaints. That's what we want. We want to get rid of education. Oh, come on.
Professor.
Yes, ma'am.
So I was reviewing some of these sample surveys you have up on Canvas, and do you think they're a good like example on how to like word these tables like when we're describing them?
Most of them are, yeah. They all scored A's. The sample survey reports. I would prefer that they, follow the format that I'm teaching you, but you have to write in your own language, in your own style, Yeah. Something's not working right. There we go. Okay, so here's another example where you can use a pivot table. So what we've done is we put level of education in the columns, and what I wanted was average of efficiencies. So let's see, I'm going to put in here efficiencies again, and what I want is the standard deviation. Oh, I hate how it does this. Okay, so let's say you wanted to calculate a lot of these statistics very, very quickly. You could, in here we dropped level of education as a way to segment what it was, and we put in efficiencies. So bachelor's degree average efficiency was 0.77 or 0.799, and the standard deviation is this. The average graduate degree efficiency was 1.34 with a standard deviation of this. The average high school efficiency was this with a standard deviation of this. So you could you can sort of build these little tables to not just put out the sums, but you could have them put out any of these little things, the minimum, the maximum, however you want. So and then you go and you clear that pivot table and you deselect the things that you don't want to have reported. So the pivot table ends up like a little machine that can do this calculation for you if you set it up the way I've just set it up for you. So I'm going to stop the share and stop the record.